Let me read this word problem for you really quick. Miss Simon drives her car from her home to her workplace every workday morning. The table above shows the distance in miles and her average driving speed in miles per hour when there is no traffic delay for each segment of her drive. So we're going to use this table right here to answer these two questions. Starting with the first one. One morning, Miss Simon drove directly from her home to her workplace in 24 minutes. What was her average speed in miles per hour during her drive that morning? So one, let's focus on what it's trying to ask for. It's asking for average speed in miles per hour. I like to write the ratio of what it's looking for on the side. That way it kind of gives me a guide on what to look for. To get speed, we got to take the total number of miles from her home all the way to her workplace. That means we got to add all these numbers up, and that's going to equal 17.4 miles. And from this word problem, it says that it takes her 24 minutes to cover all that distance. So you don't need any of this information right here. It gives us the time, but the thing is, it's in minutes. So now we just got to convert the minutes into hours, and we're done with this problem. To do that, all we got to do is multiply this by 60 minutes over 1 hour. That's how I learned to convert units. I think they call that the railroad method. Minutes are going to cancel out. Now we're in miles per hour. Multiply 17.4 times 60 and then divide it by 24, and we will get the speed, which equals 43.5 miles per hour. Done. Let's move on to question 38. If Miss Simon starts her drive at 6:30, she can drive at her average driving speed with no traffic delay for each segment of the drive. If she starts her drive at 7 a.m., the travel time from the freeway entrance to the freeway exit increases by 33% due to slower traffic. Stop right there. We're going to focus on this part of the table, so keep your eyes on that because there's a lot of words in this problem. But the travel time for each of the other two segments does not change. Based on the table, how many more minutes does Miss Simon take to arrive at her workplace if she starts her drive at 7 than if she starts her drive at 6:30 a.m.? They even underline what you're trying to solve for. It says how many more minutes will it be if this part of her drive in time increases by 33%. So first of all, how do we get time? Well, speed equals distance divided by time, like miles per hour. And to get time, time will equal distance divided by speed if you manipulate that formula. So let's focus on the middle part of that table. Let's take the distance. The distance is 15.4, and we're going to divide that by the speed that's given right there, which is 50. If I divide those two, I get 0.308, but my unit is going to be in hours, so I got to convert that once again. Times that by 60 minutes over 1 hour. So what is that going to be in minutes? That's going to be 18.48 for this portion of her drive. This word problem is saying that we got to increase this by 33%. So you can even do this mentally. A third of 18 is 6 minutes, or we can just divide that by 3 to get 6.16 minutes. And this one's a little tricky because it says round your answer to the nearest minute. We got to round down, which gives us the answer that her commute is going to increase by 6 minutes. A lot of reading on that one. You got to be careful, but hopefully it was good practice. If it was, like and subscribe, and I'll see you on the next episode. Peace.